Alright, so we know right here that we have two velocities. We have velocity 1, which is 192 meters per second. And we have velocity 2, which is 240 meters per second. Now, we know that this is a 45-degree angle with this x-axis, and this is our y-axis. So let's go ahead, and we know that because this is at an angle, that it's going to have an x component and a y component. So let's go ahead and just find our V1. So we know our V1 is 192 meters per second. So we write that down. Now V2, we know that the x component is going to be the cosine. So we know that 240 times the cosine of 45 x hat plus the y component, which is 240 times the sine of 45 degrees, will give us our V2. So let's just go ahead and simplify these, and we end up with V2 equals 170 x hat plus 170 y hat. Now let's focus on the x's. We know that the final velocity minus the initial will give us the velocity. So we know that 170 meters minus there's no change in that will give us 170 meters per second for the x. Now the y, we know that there are two velocities for the y. There's 170, which is the final velocity, and there's 192, which is the original velocity. So we do 170 minus the original, which is 192, and we get negative 22 meters per second y hat. Now, we know that to find the change in velocity, we just put the x plus the x squared plus the y squared and divide and do the square root of that to get the average. So we end up with the average velocity equals 170 meters per second. Now to find the direction it changes, we're going to go ahead, and we know that the tan is the opposite over the adjacent. So we know that the tan inverse is the y over the x, and the tan inverse of the y is 22 over the x, which is 170, and that'll give us our 7 degrees in the southwest direction.